function. Actually, I already covered the commutation function. So the commutation function, you have to know this is for whole life, mx over the dx, and this is for pure endowment. This is for pure endowment. So pure endowment dx plus n over dx. And then this is for, okay, this is for endowment. So this is for endowment and year endowment insurance. So it is combination of term insurance and also pure endowment. Because term insurance, so this is term mx minus mx plus n over the dx. So this is for term and this is for pure endowment. So endowment is, this is for term plus, this is for pure endowment. So term insurance is mx minus mx plus n over the dx, plus for the pure endowment is dx plus n over dx. So since we have same denominator, so we can straight away take mx minus mx plus n plus dx plus n over dx. So that's why we have this. So it is combination of term and also for pure endowment. Okay, so commutation function is just a very simple one. And then the last one is deferred, end-year deferred insurance. So end-year deferred insurance for the whole life case, we write like this. Okay, same as the continuous, but we don't have bar on the top of A. So for the deferred, we start from N to, because this is for the whole life, so until infinity. So the benefit will be paid after the n years. Okay, after the n years. So we don't want the benefit before the n years. There is no benefit before the m years. So we're starting from x plus n. So this is x plus n. Undo, this is t. So this is t. If it's in terms of x, this is x plus n. So we put here is until t years, let's say x plus t. Okay. Or omega, for example. So this is omega because this is whole life insurance. So we start from hx plus, and that's why for the deferred mx plus n over dx. Okay, for whole life, we start from here. We start from t equal to 0, or we start from x. So that's why we take mx over dx. But for the deferred, we start from x plus n because the benefit is paid after n years. So it becomes mx plus n over dx. So this is the alternative. This is the alternative equation to get the deferred insurance, where we can also take whole life insurance minus n-year term insurance to get the deferred. Because for the whole life, it's starting from 0 to omega. So we take all and we subtract the n-year term. So the n-year term is before n-year. So we will get the deferred here. So we will get the deferred here. So this is whole life, this is term. So whole life minus term, we can get the deferred. Okay, so if you use the whole life, So AX minus term also we can get for the deferred whole life insurance. So AX is MX minus over DX. The term insurance is MX minus MX plus N over DX. So that's why we get MX plus N over DX. This is when we illustrate it in timeline. Okay, this is for timeline. This is for timeline. Okay, if in the question ask you to refer to the illustrative life table, so you know you have to refer to the table and you have to change to the commutation function first. So for example, here is M30 over D30. So this is whole life insurance. So how about B? B is equal to MX plus N over DX because it is deferred insurance. So M45 over D35. So the third one, it is term insurance. So term insurance, we have the limitation like this. So we have M35 minus M55 X plus N over D35. This is for pure endowment because one on the top of N. So pure endowment is just about the survival benefit. So dx plus N over dx. So D55 over D35. So don't get confused, don't take dn, but it is dx. So then you can refer to the table. M30, what is M30? What is D30? What is M35? What is D35? And the last one is endowment. So this is A35 for term plus A35 for pure endowment. So you can take the values from term plus the value from the pure endowment. And then, or if let's say the H and the N is different from B, C and D, so you can find it is actually M35 minus M55 plus D55 over D35. Let's say the H and the N is different from previous question. So you can use the formula. Okay, so it is the term plus the pure endowment. So this is the definition. As the summary, it is the definition. So this is the AX. So the expected present value or the net single premium for whole life insurance of RM1 since the benefit RM1 issued to X with benefit payable at the end of the year of death because it is discrete. So this is term, you already know that it is N-year temporary life insurance, or we also call it as term insurance or term life insurance because it temporary, it only for N years. Okay, say and payable at the end of the year of death. Okay, so you can, you have to know the definition as well so that you can understand more. So this is for pure endowment, this is for endowment, and this is for the deferred insurance. So we have 5 types of insurance: whole life, term, pure endowment, and also the deferred. So actually endowment is combination of term and pure endowment. Okay, so we have exercise. Okay, so this is for continuous. I have 4 questions. You can try. So for your test 1, so for chapter test 1 will consist of chapter 1 to 3. So you can try the tutorial, this tutorial, and I will Okay, we tried number 4 first. Okay, because we have 30 more minutes. Okay, let's say I choose number 4. This is for continuous case. Okay, how we do know that it is continuous? Okay, a 7-year deferred whole life insurance of 15,000 with death benefit payable at the moment of death. So you know that it is continuous. So it is deferred whole life. So you know, you can imagine that. So this is N7, N year. So N year is 7 year. So you write down first the notation AX. So what is X? So X is equal to 20. Okay, X is always in the bracket. If we don't mention about the age, you know that in the bracket is for the X. So 20. So the deferred must have this thing. So how many years? 7 years. So M is equal to 7. Okay. Or we can use N or M. For endowment, we have another thing at the back, isn't it? So the deferred year become M. So never mind as long as you know where you want to put the value. So this is the notation. And don't forget this bar because it is for the continuous. So when you look at the notation, so you know it is continuous, it is deferred, and it is for whole life since we don't have N at the back. Okay, so when deferred, the lower bound starting from 7. The lower bound starting from 7. So it become, okay, and what kind of distribution that we use in this in this problem? We use De Morph's law. So you know that De Morph's law, the upper bound is omega minus x. So the omega is 110, delta is 0.08. So now we can find, okay, and this is the benefit, 15,000. So benefit we can put outside. This is how you extract the information and put into the equation. So you just leave the 15,000 outside the integration because it is constant. Okay, so for the deferred, the lower bound is the M here. So 7. What is the upper bound? Because it is De Morph's law, the upper bound is omega minus x. So omega is 110, x is 20, 110 minus 20. So what must be consist in the integration? Vt times Tpx mu x plus t dt. So what is the Vt? E negative delta t. E negative delta t. So the Tpx mu x plus t for the De Morph's law is 1 over omega minus x minus t. 110 minus 20 minus t dt. So you have to refer back what is the Tpx for De Morph's law and what is the mu x plus t for the De Morph's law. Tpx times mu x plus t, then we get the 1 over omega minus omega minus x. Omega minus x. Because Tpx for De Morph's law is omega minus x minus t over omega minus x. Mu x plus t is equal to 1 over omega minus x minus t. That's why when we times Tpx mu x plus t, we can cancel this out. And what left? Only 1 over omega minus x. Now you can solve this problem. 1 over 90, also you can take it out from the integration. Okay, so it becomes, so you just integrate E negative 0.08t. Sorry, now we have 7 there. Okay, if this case, okay, 7 to 90 is 83. T is equal to 83. So if I also want to use, okay, because I like if the lower bound is 0, because I just straight away put 1 minus. Because e equal e the power of 0 become 1. Or you also can write as 0 to 83, because the bound 7 to 90 is 83 years, isn't it? So E, so it becomes, you take 90, take out the 1 over 90, 1 minus E. Sorry, lagi you confused pula. Tak apa, I put lagi another step here. So what left? We take out 90, E negative 0.08t dt. So we just integrate E negative 0.08t and you will get 1 minus E negative 0.0883 over ada kelas. So you can get these values. If you don't want to change the lower bound to 0, you can also calculate from here, but you have to put 15,000 over 90. So E negative 0.08 over negative 0.08, because you integrate 7 to 90. So you so this here is T. So you substitute 90 minus 7. Okay, you substitute T. So suppose we have the same answer. Okay, so far so good. Do you have any question before our test 1? So chapter 3 is included in test 1. Okay, we try one more question for discrete. So okay, using the expression, so you just need to use commutation function. So it doesn't, you don't have to refer to the table. Just want to know, okay, never mind. You can refer to the table for the ILT. Okay, we try number 1. So whole life for this case is, okay, we put benefit outside. So whole life is X. So X here is 35. And then what is A35? It is MX over DX. So 15,000. You refer to the table M35 and D35 and you can get the answer. So for the second one, it is 10,000 A15. Sorry, not 15-year endowment insurance of 40. So X is equal to 40. So 40, how many years? 50 years. So endowment. So endowment is, how to find the endowment? 10,000. So MX, M40 minus MX plus N, M55 plus DX plus N, D55 over D40. So you refer to the table, what is the value for M40, what is the value for M55, and what is the value for D55 and D40, and then you substitute the values and you can get the answer. And this is 5,000 A30 5-year term insurance, N is equal to 5. So term insurance, we have 1 on the top of 30. So this is X. This is N. Okay, so what is the term insurance? 5,000 times MX is M30. MX plus N is M35 over D30 over the DX. Okay, then you refer to the table. And the last one is for the deferred insurance. So deferred insurance start from age is 27. 3-year deferred insurance. So 3-year deferred insurance. But we don't have any years. How many years at the back? So we know that it is for whole life. Just remain at like that. So MX plus N over DX. So 5,000 times MX plus 1, MX plus N is 30 over D27. Don't put D30. D must always use the current age. So D27. If you put D30, it just same as the whole life insurance, starting age 30. Okay.